Moving on to section 8.3, we're going to be looking at how to solve simple inequalities. And so our goals are going to be able to use substitution to determine whether a given number is a solution to an inequality or represent the solutions of an inequality on a number line. And when we talk about an inequality, that just means that there might be more than one possible answer for our problem. Okay, it's not always equal to one exact number, that there could be more than one answer to our problem. Okay, and you've worked with inequalities before in elementary school when we compare numbers, greater than, less than, greater than or equal to, or less than or equal to. Those should be familiar to you. Okay, so we're going to be looking at problems and how to set up an inequality, and then how we're going to graph them on a number line. So just some math notes for ourselves here, that when we do start graphing, that an empty circle indicates that the value below the circle is not a solution of the inequality. So that would be for our greater than or our less than symbols. That would be an open circle that we're using those two. And then when we have a shaded circle, that would be for our greater than or equal to, or our less than or equal to inequalities, that when we're graphing that, we're going to show it with a closed circle. So good to take note of those beforehand before we start solving and setting up our inequalities below. So taking a look here at Learn 1, our job is to be able to determine solutions of the inequalities using x is greater than c or x is less than c. And those could be any numbers, right, given the problem. We're going to write our inequality and then graph the solution. So taking a look at problem number 1, it says a bag of tomatoes weighs more than 5 pounds. We want to find 3 possible weights of the bag of tomatoes. We're going to write our possible weights as an inequality and then represent the possible weights on a number line. Okay, so I'm going to pick a variable for my weight. I'm just going to use W to represent my weight. And when I think about this inequality, I want to show that any possible weight of the tomatoes would be more than 5 pounds. So I want to show that this weight would be more than 5 pounds. It's greater than our 5 pounds. So that would be setting up my inequality, showing the weight is greater than 5 pounds. It's not going to include 5 pounds, it's just greater than our 5 pounds. Okay, when I'm drawing a number line to show our possible solutions for what the weight could be, just like we did in the beginning of the school year, we're going to put the number given to us, which would be 5, right in the center, and I want you to pick 2 numbers greater than and 2 numbers less than with an equal interval to be able to set this up. So I'm just going to count by ones and put 6 and 7 and then 4 and 3. So I've set up my number line here. In showing any weights that are greater than 5, I see that this is just a greater than symbol. If I look up at my math note, that when I have greater than or less than, I have to use an open circle. So I'm going to put an open circle on 5 and now shade in to show all of the possible weights that W could be, anything greater than 5. So that could be 6, that could be 7, that could be 100, really anything that would be 5. It would not include 5, it just has to be greater than 5. And that is what we would write down for problem number 1. We've written our inequality, and then we have our graph. Okay, let's take a look at number 2 with this jar here. So on the jar, the label says to store below 20 degrees Celsius. So I'm going to use T to represent our temperatures. So the temperature here has to be below 20 degrees Celsius or less than 20 degrees or 20. So my inequality is showing that any temperatures less than 20. I'm going to take this inequality and now draw my number line. Placing 20 in the center, picking my next two numbers above and my two numbers below. I'm going to graph my point on 20. If this is less than, that means it's going to be an open circle. So I have an open circle on 20. If it's less than, now I want to shade in all of my possible answers that would be less than 20. So 19, 18, 0, -5, anything that's less than 20. Okay, looking at the next session, we're going to use substitution to determine 3 solutions of each inequality, then represent the solution set of each inequality on a number line. So I'm going to start with drawing out my inequality on my number line. I think that's going to help to then figure out numbers that could be for the variable. So number 3 showing h is greater than 8. So on my number line, I'm going to start with 8. I have 9, 10, 7, and 6. My inequality symbol is greater than. That means that I have an open circle on 8. And I want to show everything that would be greater than 8. So shading to the right on my number line. So h could be 9, h could be 10, h could be 11. Any numbers greater than 8 would be possible solutions. And that's all I put for number 3. With problem number 4, same thing. I'm going to start out with my graph, my number line, showing y is less than 1.5. I'm going to pick an interval here of counting by 1/2. So then my next number would be 2, and then 2.5. I need to have an equal interval here. On the other side, I have 1, and then I just have 1/2. I'm working with an open circle with less than. And I'm going to shade everything that would be less than 1.5. So going to the left on my number line. So possible solutions for y could be 1, could be 1/2, could be 0, anything less than that. Looking at problem 5, p is greater than -2. So if I have -2 here, going to the right, my numbers are getting bigger or closer to 0. So I count -1, then 0. I have -3 and -4 on the other side. Greater than is an open symbol. And greater than should be going to the right, showing all of the numbers bigger than -2. So p could be -1, 0, 1, and anything else to the right. And number 6, e is less than 14. I'm going to start with my graph. 14, then I'm going to count up 15, 16, 13, and 12. I'm going to put my open circle on 14. E is less than 14, so I'm going to shade everything to the left. That would be less than 14. So E could be 13, could be 12, could be 11. Again, anything less than that. Okay, moving on to learn 2. Same idea. Now we're looking at solutions that would be greater than and equal to, or less than or equal to, and we're looking at some of these word problems and translating them into inequalities here. So with number 7, reads, Anna needs at least 7 feet of ribbon for her crafts project. Our job is to find 2 possible lengths of ribbon that would be enough to complete her project, and then represent the possible lengths as an inequality and graph it. So let's say if we're talking about lengths of the ribbon, we'll just represent r as being our variable for the length of the ribbon. If it's sharing that she needs at least 7 feet, that means she could use 7 feet, and really anything else, anything bigger than 7 feet, that's the lowest amount that she could need. So when writing our inequality, we want to show that R would be greater than or equal to 7. So she could use 7 feet, but she also needs more than that too. She could use more than that. So that would be our inequality that we're going to graph on our number line. So 7 in the middle, 8, 9, 6, and 5. My inequality symbol looks different than the previous page, where I have this line at the bottom showing that it's greater than or equal to. So on my graph, I need to reflect that when I'm drawing my point, I actually have to shade it in to show that 7 would be included. My direction's still going to the right to show that R is greater than or equal to 7, so all those bigger numbers than 7. Okay, 2 possible lengths that she could use would be 7 or 8. You could pick any 2 that would be equal to 7 or greater than that, but listing here for us, we could choose 7 or 8 feet. Let's look at another one. On one winter day, Helena, Montana had a max temperature of -4 degrees Celsius. Find 2 possible temperatures. We're going to write an inequality and then represent them on a number line. So picking our variable, let's use T again for temperature. If the problem is saying that the max temperature is -4, the maximum, that means that that is the highest that it could be. Okay, that any other possibilities would have to be less than or equal to -4 degrees. So in my inequality for my temperature, it would have to be less than or equal to -4. -4 would be the greatest possible temperature. Our temperatures could be anything less than or equal to it. So now that I've come up with my inequality, I'm going to graph it on my number line. -4, -3, -2, -5, and -6. Since it has that equal to part, I'm going to shade in my point on -4. And then I want to represent all the possible answers that would be less than that. Okay, so possible temps could be -5 or -6. We could also use -4. We could do -4.5. Doesn't have to be whole numbers every time. Anything in between also includes fractions and decimals would be included as well. All right, moving on to 9 and 10, use substitution to find 3 solutions of each inequality, then represent the solution of each inequality on a number line. So if m is greater than or equal to -28, we could do -27 is greater than or equal to -28. -26 is greater than or equal to -28. -25 is greater than or equal to -28. So those are 3 possible solutions plugging in for m. On my number line, I have -28, -27, -26. On the other side, getting more negative or smaller. Since this includes equal to, my point on -28 is going to be closed, and I want to shade everything that would be greater than that, so shading to the right. Moving on to number 10, I want to pick 3 different numbers that I could substitute in for D that would make the statement true. So D could be 1.5. 1.5 is less than or equal to 1.5. 1 would be less than or equal to 1.5. And even the decimal of 0.5 would be less than or equal to 1.5 as well. So those would be 3 possible solutions. You could pick others. Those are just the 3 that I'm showing you here. I'm going to now graph my inequality, placing 1.5 in the center and counting up at an equal interval. So I'm going to count by 0.5. I have 2, then 2.5. I have 1 and 0.5. My solution set includes 1.5, so I'm going to shade that in. And then I want to shade in also what would be less than 1.5, so going to the left. The last part here, you're given 4 different inequalities up at the top, A, B, C, and D. Down below are pictures of those graphs, so we're going to match our picture of our graph to the inequality. So starting with number 11, I see that there's a closed dot on 10, so that means it has to be equal to, and it's showing all the solutions that would be less than 10. So x is less than or equal to 10. If I look up above for the inequality that represents x is less than or equal to 10, I can see that choice B matches up there. So for number 11, my answer is going to be B. For number 12, I have an open circle on 10, and it's going in the direction of all the numbers that are greater than 10. So I'm not going to include 10. I just want anything that's greater than 10. So looking between choices A, C, and D, x is greater than 10. Choice C is our best fit for graph in number 12. So number 12 should be C. Number 13. For number 13, we're looking at a closed circle on 10, and then going in the direction of numbers that are greater than 10, so greater than or equal to 10, which would be choice D. And last but not least, for number 14, we're left with choice A, showing that x is less than 10. Okay, go ahead and submit your notes if you are done. Be ready to come to class with questions if you have them.